Hello, hello, hello. Algebraites, our goal for today is to find the equation of a line that's parallel or perpendicular to a given line. So by way of warm-up right here, please take a moment to graph each one of these. Graph this line here, graph this line here, and graph this line here. So first we need to label our axes here, and I'm going to throw a few numbers down. Remember, we don't have to write every single number down, just a few of them here. Now go ahead and pause and come back to see the results. And here we go. These are my three lines. So what's something they all have in common, and what's something that might be different? For our sake, I'm going to label these a variety of different names. So this one I'm going to call Y3, and then this I'll call Y2, and this one I'll call Y1. Now pause, think about it, write your answers down. And here are a few suggestions. Now let's take a gander. Parallel lines. Well, clearly it turns out that these, the blue and the red lines, are parallel. Now what makes them parallel? There are two things that make it parallel. Number one, notice that for every time that this line goes up a certain amount and goes right a certain amount, this one also goes up that same amount and right a certain amount. And it looks like I messed up here, so let me clean this up real quick. And there we go. I just adjusted the red line a little bit because of the slope. All right, so parallel lines. What's true? Parallel lines have same slopes, and they have different y-intercepts. So like I said, with this blue line, it goes up 3, right 1. The red one goes up 3, right 1. But they also begin, if we call this the beginning, different locations. Another key thing we must point out is that since vertical lines don't have slopes, vertical lines are parallel as long as they have different x-intercepts. Okay, now down here, let's determine if any of the lines graphed here are parallel. Now, these two here, and we're going to label them different. We'll call this one Y1, the red one, and we'll call the blue one Y2. Now, clearly they look not parallel. They look not parallel. So we're going to verify that. With the red one, it looks like from this point to this point is a nice clean one. So down 1, 2, 3, 4, 5. So the slope of this one is down 5 and right 1, 2. So that's -5/2. But let's look at the blue one here. Looks like here's a good nice clean point, and here's a nice clean point. So going up 1, up 2, up 3. So this slope is up 3 and then left 1. So that's a -1. So notice the slopes here are different. So determine if any lines within this graph are parallel. And here, our conclusion is that they are not parallel. And this symbol right here, with a slanted double line there, I use for parallel. So they're not parallel. Why? Because their slopes are different. Now these two lines, to me, they look parallel. But we don't just say they look parallel. Let's go ahead and decide if they are parallel. Call that one Y2 and call this one Y1. So for Y1, this looks like a good place, and this looks like a good place. So the slope here, quickly, is 1/2. And the same thing applies down here, and the slopes is also 1/2. So my conclusion here is that Y1 is parallel to Y2. If asked to explain why, because my slopes are the same, and my b's are different. What about over here? Well, we've got 3 different lines. So we've got this top line, middle line, and bottom line. So let's go with what our instinct says. These two look parallel, and these two look not quite parallel. This one looks like it's a little tighter here than here. So let's just figure things out. From this point to this point, my slope here for my Y1 looks like it's about 1/5. Goes up 1 and then right 5. How about this for y2? Well, my slope here goes from here to here, and notice that's also 1/5. Well, what about the green one? From here to here. We see up 1 and then right 1, 2, 3, and 4. So y3 has a slope of 1/4. So what's our conclusion? Well, we've got a few conclusions. Number one, y1 is parallel to y2, but we can also conclude that y1 is not parallel to y3 because the slopes are different, and y2 is not parallel to y3 because they are different slopes. But we're only focusing on the parallel for this. All right, down here. Find the slope of each line and match any lines that are parallel. So, first off, this is in slope-intercept form already. So this slope is a 2/3. This slope here is a 2, and this slope here is a 0.5, or another way to say that is 1/2. So let's look over on this side. This slope here is 1/2 also. So that looks like they match. Let's see. They also have different y-intercepts. So these two are parallel. How about this guy here? Well, this has a slope of -2/3. But notice we're tempted to say, oh, well, this has got to be -2/3, +2/3. Those are the same, aren't they? Nope, negative, and that's positive. So those are different. So that means these are not parallel. Won't make any mention about that. Lastly here, this one here. Looks like this slope is 2. So m is 2. So I'm thinking, okay, so that's got to be, that's a 2 here and that's a 2 here. So those have to be parallel, right? Well, look, the y-intercept here is -1, but the y-intercept here is also -1. So those two, 2 and C are the same line because they have the same M and the same B. So they're not parallel, they're the same. All right, let's go to the next page here. And we're going to determine if the lines are parallel. I'll do the first one, and I'll let you consider the other ones and pause. So how do we determine if the lines are parallel? Well, we're going to rewrite the equations in slope-intercept form, and then we're going to compare the slopes. Well, this one's already done for us. So right here, we see that the M is 3, and the B is -8. So for this one down below, I'm going to rewrite it and get y by itself. How do I do that? First, I'm going to subtract the 3x from both sides, like so. I'm going to bring down the -y, -x, 3x, and -1. And now I'm going to multiply both sides by a -1. And in doing so, I'm essentially oppositifying all the terms, like so. So notice that here, I see that my slope is 3, and the B is 1. So determine if the lines are parallel. And the answer is yes, they are parallel. When asked for a reason why, our reason is because the slopes are the same and the B's are different. All right, now take a moment to consider these ones and then pause and come back for the answer. And here we have our conclusions. When I get this in slope-intercept form, here's my slope, and I get the red one in slope-intercept form, here's my slope. Different slopes, not parallel. Over here, both the slopes are 0, and the y-intercepts are different, so they are parallel. Equations of parallel lines. We're going to write the equation of the line that is parallel to the given line and passes through the given point. So it passes through this point, but is parallel to this. So let's walk through and see what our steps, what we're going to do. Number one, we're going to identify the slope of my line. We're going to write in slope-intercept form, point-slope form. Then we're going to distribute out the slope and convert this to slope-intercept form. So the first thing here, notice that the slope of the given line is 3/4, which means my slope has to be 3/4. Why? Because parallel lines have the same slope. we can ignore the plus 2. Next, we're going to take the 8, the 9, and the 3/4, and we're going to plug it into y minus y1 equals m times x minus x1, also known as point-slope form. So let's go ahead and do this. So y minus 9 is equal to 3/4 x minus the 8 there. So that is, if the question asked me up here to write it in point-slope form, this would be my answer. I would stop, because point-slope form has a slope on the outside and usually has parentheses. But we are going to go a little bit further, so I'm going to distribute the 3/4. So I get 3/4 x minus 6. Again, how do we get that? 3/4 of 8. If you want to see that real quick, 3/4 of 8 is 6. 3/4 times 8. Remember that the 4 and the 8 reduce to a 2 and a 1, and then 3 times 2 is your 6, and I'm just bringing down that negative. All right, now we're not done, because we're going to write this in slope-intercept form by adding 9 to both sides, and so my final answer here is 3/4 x plus 3. Now we know this is parallel because it has the same slope as this one and different y-intercepts. So how can we check this? Well, I'm going to use Desmos to do that. So let's look here. So here's my first equation, and here's the point. So I want this line to it to be parallel to this line, but passes through that point right there. So I selected, and that's my answer that I end up calculating. And notice that it passes through that point right there, and we're good to go. We've done a check. Now pause and take a few minutes to do B and C, and then come back and check your answer. And there we go. And now do the same thing here, and obviously check your answer accordingly. Now, when we look back at the warm-up, what we noticed here was that we had two lines, a y1 and a y3, and it turned out that this slope was a 3, and this one had a slope of negative 1/3. And as we looked at the two lines, one was like this and one was like this, it turns out they were parallel. Now the scale might have looked funny, so it was hard to tell, but they were indeed. So here's the key thing about perpendicular lines. Perpendicular lines have opposite, reciprocal slopes. So what do I mean by opposite reciprocal slopes? For example, if I have negative 2/3 is one of my slopes, then the other slope has to be the opposite of that, so it's plus, and reciprocal means I flip the fraction like that. Just to give you another example real quick, is you could have said if I had 4. Well, what's the opposite reciprocal of that? It's going to be negative 1/4, like so. So there we go. What is also true is that any horizontal and any vertical line are perpendicular. And this is my super secret symbol for the word perpendicular. Speeds up the process. So we're going to find the slope of a line that's perpendicular to the graph of each equation, identify the slope, then we're going to find the reciprocal and take the opposite. Now sometimes people say negative, take the negative, which later in this PDF will show you that. All right, so quickly I identify here the slope of 3/7. So that's the given slope, 3/7. So opposite means negative, and reciprocal means I have to flip those to be 7/3. So that would be the slope of my equation. Please take a moment and do those, and pause and come back. And check your answers here. Now the final thing we're going to do in this video is we are going to do what we did before with parallel lines, only this time with perpendicular. We're going to write the equation of the line in slope-intercept form. So just to give us some information, slope-intercept form, y equals mx plus b of the line that is perpendicular to the given line and passes through the point. So notice the first thing I can do here is identify the slope that's given to me. So my slope is the opposite and the reciprocal. Now I'm going to take that 8 and that 9, and we're going to substitute everything into y minus y1 equals m times x minus x1 point slope form. So substituting in, y minus 9 is equal to my slope, let's get that right, my slope is negative 4/3. And x minus 8. Now, if we were asked again, if the question up here said write it in point slope form, we're done. No more to do. But we do have to continue because we're going to put it in slope-intercept form. So I'm going to distribute the negative 4/3, double negative there, and 8 times 4 is 32, and the 3 stays on the bottom. Okay, now the last thing we have to do is I'm going to add 9 here, but I'm also going to add 9 there. Now, why am I ghosting it like this? Because 9 is the same as 9 over 1, which is the same as 27 over 3. What did I do? Multiply that by 3 and that by 3. Why? Because of this 3 right there, we need to have a common denominator. So what I'm going to write here is say plus 27 over 3. Now, when I cancel those out, I get negative 4/3 x plus 59 over 3. And as ugly as that seems, that's okay. That is my answer. All right. Work through these problems and come back and check your answer. And here you go. Now the same thing is going to happen here. Now let me just show you graphically what's happening here. Notice that's this slope. If I start here and go down to this nice place here, it goes down 1, down 2, down 3, right 2. Okay, so now I'm going to go, in this one, I'm going to go up 2 and right 3. So to this point right here. So when I graph it, notice that we are going to have a perpendicular line right there. So notice that in doing this, we actually have my y-intercept there, and we can count my slope. So since my slope is the opposite reciprocal, that is, it's positive 2/3, and the b I can just point to, this right here, is a 2. So now my answer, very straightforward, is y equals 2/3 x plus 2. Notice there wasn't really any work doing. All I did was evaluate the slope and then see where it crossed the y-axis. The same thing can be done over here. What's the slope of this line right here? It looks like it passes neatly through here and through there. So 1, 2, 3, 1, 2, 3, 4. So the slope is 3/4, which means my slope is negative 4/3. So we already have that answer, or excuse me, that part of the answer. And now if I go ahead and do that, down 1, down 2, down 3, down 4, right 3 to there. Notice in drawing this line, not very straight, these lines are perpendicular, and here is my y-intercept. So I need the plus 0, or I don't write it at all. And there we go.